This video discusses voltage boosters used for LED backlights and the aspects of this application for Schottky diodes. Compact modern electronic communication and computing devices like smartphones and tablet PCs need smaller components to allow very thin designs. Products with LCD displays use LEDs as backlight. These are configured as a string. As the string needs a higher voltage than the battery can provide, a voltage booster circuit is required. The diagrams show the simple structure of such a booster that consists of a switch, an inductor, a Schottky diode, an output capacitor, and a controller IC that controls the switch and senses the output current via the input I sense. The maximum output voltage is limited via V-sense. Let me explain the way the circuit works. While the switch is closed, the current in the inductor increases and magnetic energy is stored. The diode prevents a reverse current to flow from the output capacitor. When the switch opens, the current continues to flow through the conducting diode and decreases with a linear waveform. The current charges the output capacitor now. The described process is repeated with every switching cycle. The output voltage Vout depends on the duty cycle of the switch. If all losses are neglected, Vout is equal to the input voltage Vin divided by 1 minus the duty cycle D. Vout increases steeply if the duty cycle D gets close to 1. The diode's time of conductance gets small with an increasing boosting factor, so a low Vf is important due to the high diode pulse current compared to Iout. Schottky diodes are able to switch very fast and support the requirement of low forward voltage losses. NXP's DFN1608 Schottky diodes are a very good choice for backlight boosters in tablet PCs and ultrabooks. The package size is 1.6 mm by 0.8 mm and a height of 0.37 mm. The side pads are solderable and allow a visual solder joint inspection. The forward current ranges up to 2 amp for this package, and VR ranges from 20 to 40 volt. The next smaller package is DFN1006, with a length of 1 mm, a width of 0.6 mm and a height of 0.37 mm. It has the same features as the DFN1608. The maximum forward current for this package is 1 amp. But it can be even smaller. NXP introduced Schottky diodes with a size of 0.6 mm by 0.3 mm with a height of 0.3 mm. Although very small in size, these diodes have an outstanding electrical and thermal performance. The maximum average current rating is 0.5 amp, whereas the IFSM rating is very high because no bond wires are needed in this CSP package. NXP's latest development are DSN1006 diodes in CSP technology. The height of these parts is 0.28 mm only. The table shows the first products of this new diode family. A small demo board shows an example of a voltage booster designed for an LED load. Either DFN1006 or DSN0603 diodes can be assembled. Additional key components of this current source are a boost controller IC, an inductor and a current sense resistor. Here you see the demo board running in different operating conditions. The sequence starts with the setup using a 1 watt white LED load. The output current is 350 mA. Now the booster works with a string of 3 1 watt LEDs, and finally we have a setup with a single battery as an input voltage and a string of 3 white standard LEDs as output load. Thermal simulation results are shown here for the two mounting options of the Schottky diode. The evaluated condition is an input voltage of 1.5 volt and a white 1 watt LED used as a load. The maximum package temperature of the Schottky diodes for an ambient temperature of 25 degrees does not exceed 70 degrees Celsius. This test proves that even NXP's smallest Schottky diodes are sufficient for backlight units in smartphones or similar small applications. This means that leadless products can replace bigger conventional parts without compromising performance and reliability.